Non-standard model. Fundamental particles. An alternative to the standard model. More intuitive and simpler. Here is why. Summary. The non-standard model of a fundamental particle is based on the following. Two elementary particles. One energy field. That's all. Elementary particle. The photon. 中 plus and 中 minus. When the photon is in the right hand configuration, it is noted plus, otherwise it is noted minus. Elementary particle, the second one. Pure electric charge. You have the minus charge and plus charge. Noted co. The energy field. The energy field, gu. It is modeled as consisting of elements infinitely smaller than the photon and pure electric charge, denoted gu substance. It is responsible for the photon's motility. It is responsible for electrical interaction. It is responsible for magnetic interaction. It is also responsible for gravitational interaction. The exact mechanism remains to be discovered, but experiments show that the gu field is conservative. Gu substance is sensitive to gravitation. Structure of an electron. An electron is composed of an electric charge which captures a photon. A negative charge captures a negative photon. The photon remains trapped in the charge cavity. The electric charge will rotate with the photon's momentum. It is similar for the positron. It's the pure electric charge co plus captures a photon zhong plus, which remains trapped in the charge cavity. The electric charge will rotate with the photon's momentum. The origin of forces. All forces are the sequence or the consequence of the interaction of particles with the energy field gu. Electric force, magnetic force, and gravitational force. Formulation of electric force. An electric charge disrupts gu field. The effect is inversely proportional to the distance. Force is the derivative of energy. Hence, this force is inversely proportional to R square r power square. So the Coulomb force is modified to the following formula. And F is the electric force, epsilon 0. 0 is the dielectric permittivity of a vacuum. R is the distance between the two electric charges. R is its vector. Beta is a constant. QE is the weighted electric charge, number I, QI, with I equal to 1 or 2. Formulation of the weighted load, or weighted charge. The weighted charge of an electric charge is defined by the following formula. Q equal to E multiplied by Zhong on the Zhong-Hef, where E is the unit electric charge, Zhong is the neutral charge that the electric charge E contains. Zhong-Hef is the neutral charge of the reference electron. The reference electron is the one used to determine epsilon 0. Formula for gravitational force. A photon disturbs the energy field Gu. The effect is inversely proportional to the distance. Force is the derivative of energy. Hence, this force is inversely proportional to r power square. So, Newton's force is modified to the following formula, where F is the electric force, G the amplitude coefficient, r is the distance between the two photons, gamma is a constant, Zhong I is the neutral charge of photon I, with I equal to 1 or 2. Formula for magnetic force. An electric charge has a rotation that creates a vortex in the Gu field. This is the origin of magnetic field lines. The wording is long, so see the website for details. The origin of inert mass. The origin of the inert mass is linked to the displacement of the electron or position. Indeed, the basic building blocks of all palpable matter are the electron and the position. The movement of an electron leaves a series of holes behind it that do not disappear immediately. Such a hole will disappear when the vortex, the electron generated, is completely exhausted. Since the energy field Gu is conservative, the energy of the vortices is returned to the electron. As long as there is no loss of energy, the electron keeps the same speed of movement. If the electron is accelerated, the speed increases, and the number of holes left behind increases. Therefore, more energy is required. Structure of a neutrino. A neutrino is composed of an electron and a positron. One turn around another. One turn on the other. This structure is called charginate because neutrino is defined in standard model, but in non-standard model, this model, it has a different definition. This structure is called charginate. Indeed, there are different energy levels for the charginate depending on V. V is the rotation speed. Rotation of the charginate reveals electrical neutrality, and a charginate is symbolized by a yin and yang symbol. Structure of an up quark. Three charginates form a stable triangular chain. This stability is ensured by the electric force at the three contact points of the three charginates. The green charginate has an orbital speed of 3v. This positron-free structure is called chrominate up. This compound particle is electrically neutral, and it is invisible. If we locate a positron at the center of this chrominate up, we obtain a structure. This structure with a positron is called an up quark. This combined particle has an electric charge E+. Structure of a down quark. Three charginates form a stable triangular chain. This stability is ensured by the electric force at the three contact points of the three charginates. The blue-orange charginate has an orbital speed v. This electron-free structure is called chrominate down. This combined particle is electrically neutral. It is invisible. If we locate an electron at the center of this chrominate down, we obtain a structure with electron. Is called a down quark. This combined particle has an electric charge E-. Structure of a neutron. Starting with an up quark called the core, the construction continues with the same principle as a quark on its three sides. We obtain a neutron. There are two down quarks and an up quark at the edge. This electrical balance is 2E- plus 2E plus equal to 0. Representation of the neutron. The neutron has an axis of symmetry that passes through the center of the core and is parallel to the three charginates of the core. The view along this axis can be represented by the diagram opposite. Structure of a proton. Starting with a down chrominate, called the core. The construction continues with the same principle as a quark on its three sides. We obtain a proton. There are two up quarks and one down quark at the edge. The electrical balance is 2E plus 1E minus equal to E plus. Representation of the proton. The proton has an axis of symmetry that passes through the center of the heart and is parallel to the three charge net of the heart. The view along this axis can be represented by the diagram opposite. Structure of a deuterium nucleus. The deuterium nucleus consists of a proton and a neutron. Leaving aside the position in the neutron core, the distribution of electrical charges in the neutron is symmetrical to that of the proton. This E plus E minus symmetry naturally creates three electrical bonds through the Coulomb force. Structure of a tritium nucleus. The tritium nucleus consists of a proton and two neutrons. Starting with deuterium, the second neutron is placed on the symmetry with that of the first. The bonds are the same as those of deuterium. Structure of a helium nucleus. The helium nucleus consists of two protons and two neutrons. Starting with two deuterium nucleus, they are placed in parallel so that their axes are opposite. The bonds between them are in four groups of E plus E minus. This structure is stable. Complex structure. The nucleus of uranium-196 consists of 92 protons and 104 neutrons. This nucleus has no dynamic bonds and is therefore no radioactive. When the positive charge of the structure reaches a certain limit, the repulsive force will be greater than the attractive force of a static proton-neutron bond, and it is no longer possible to increase the structure. Dark matter members. You have here a certain number of members of dark matter. You have charge net equal to neutrino and chrominate and double chrominate and triple chrominate and full chrominate. All structures presented here are stable. That's why they can constitute the family of dark matter members. Here is the muon family. You can have two down chrominate with an electron at the center of one of the two down chrominate, or two charge. Each chrominate contains one electron. The two others are symmetrical to the first one. First ones. The pions are constituted of two chrominate, one up and one down chrominate. If you put one positron into the up chrominate, you have a quark up. If you put two charge, you have a pi 0. The first one was pi plus, and the last one is the pi minus. And the second line is a symmetrical pion pi. Kaon family. Kaon family are composed of three chrominates with at least one chrominate is charged in positron or electron. This is the first group. Here is the second group. Internet links for more details. https nonstandardmodel.org http jax.dom.free.fr